Here we go. So welcome back, everyone, to the last lecture on the course in healthcare bioethics and the last lecture for the entire program in bioethics, the Masters in Bioethics here at St. Thomas University. Always beginning with a little prayer. In the name of the Father, the Son, and the Holy Spirit. Come, Holy Spirit, fill the hearts of your faithful and kindle in us the fire of your divine love. O Lord, send forth your Spirit, and we shall be recreated. You shall renew the face of the earth. Amen. All right, so before going forward, any questions or comments? Previous lectures, anything? The program itself? You know that you'll be graduating in a week or two, right? But then commencement is going to be in May, because now we only have one commencement ceremony for every academic year, and it's at the end of the academic year. So you'll have to wait about 5 months to walk, but do come back in 5 months, all right? Okay, if there are no urgent questions or comments, we're going to go forward, and this being the course in healthcare bioethics, going to finish the course with transplantation bioethics, the bioethics of transplanting organs and tissues. And I always like to end with a happy lecture, if you will, right? You've noticed we've covered so many controversial topics, beginning of human life, end of human life, the environment. And so I always like to end with a positive note on the last lecture, and there's no need for a summary on this lecture either. With regards to transplantation, then basically we can look at two sources of organ and tissue donation, which are living or cadaveric from deceased persons. So right away, you see that a host of bioethical issues come up. For example, in cadaveric organ donation, the whole issue of the determination of death, which typically is going to be which kind of determination of death, the cardiopulmonary or the neurological for organ donation. Which one do you think? Both can be, but usually the one that is used the most is going to be neurological, brain death, right? Because we're looking for the organs to still be alive while the person has been declared legally dead. So already you see controversy arising in the issue of transplantation. Let's see. All right, so let's get a little bit into it. First, some nomenclature to understand the process and what's involved. Typically, there are three types of organ donations. It can be a autologous or autograft, meaning from self. What could be an example of that? Anyone can think of some example of an organ or tissue donation of self. For example, if there's a burn, a skin burn, burn wound, skin from another part of the body to heal that wound, or a graft, bone graft for oral surgery, for example, to rebuild the bone on the jaw. Another one is stem cells, adult stem cells, right? Remember when we talked about the stem cells, that there are an increasing number of stem cells that are being discovered as sources in the body, including in the blood system. So stem cells could be extracted from the blood of a patient with some kind of knee injury for reconstruction, for healing of that injury, all right? So there are a number of possibilities for self-transplant. But the most common one, of course, is from another person, from another body. And so that's going to be allograft. An allograft comes from another donor that is not self. And so right away, what issue comes up with regards to accepting or rejecting that organ or tissue? The whole issue of the immune system, right? Because then for the For the patient, that organ or tissue is going to be a foreign body. And so the immune system is going to try to kill it, right? So we have to deal with the immune system of the patient, of the recipient. The third one is xenotransplantation, which involves from different species, transplantation from one species to another. In the human, typically, it's been pig heart valves for the human heart, because it turns out that the pig heart is very similar anatomically to a human heart, all right? So either the mitral or tricuspid valve have been used from pigs to human hearts. Yeah. Mm-hmm.
Do we run into issues when we're using other species as far as the body rejecting it? Like, is it the same rate as it would a human?
Right. So it's even harder. There's even less compatibility in between species, right? And so in the case of pig hearts in particular, typically what they do, they strip that valve so much that practically what's left is very little, the ligaments and the cartilage and so forth, right? But still, the whole issue of, we're going to talk about now in more detail, the immune rejection. The bottom line is that the patient has to be put on immunosuppressants to tone down their immune system, not shut it down totally, because then they become susceptible to anything, but to tone it down, all right? So it's a graduation thing. It's a gradual issue, immunosuppressants. They're used typically in transplantation. So let's look at that a little bit. First, what organs can be transplanted, and so a little review of the vital organs of the body. Remember when we talked about in end-of-life issues, where we started by just reviewing the vital organs of the body: the heart, the kidney, the liver, the lungs, pancreas, intestine, thymus. All of these organs can be transplanted. And the most common ones are the kidney, the liver, and the heart, right? Those typically are cadaveric. For living organ transplant, living organ, the kidney, the liver, and the lung can be transplanted. And the donor, of course, can keep on living. So that's the silver lining about living organ transplantation. We'll talk in more detail about it a little later. Let's, for tissue, there's a broader variety of tissues that can also be transplanted. Bone marrow. I mean, bone marrow transplantation has been done for decades, and it is a type of tissue transplant, right? Tendons, cornea, skin, the heart valves, nerves, veins, stem cells, again, from one part of the body to the other. The most common are the cornea. For example, the Lions Eye Bank, the Lions Club is one of these benevolent organizations in society. It's a fraternity, and they specialize precisely in transplanting or managing the transplantation of corneas, right? And it's known as the Lions Eye Bank. And the musculoskeletal system also for tissue. Now, tissues can be frozen and banked, which is another advantage. So they last longer, really. But for organs, they have a lifespan, and typically the window is within 24 hours, more or less. So it has to be done quickly, and a lot of work, background is done before the transplantation. So typically patients who need a transplant get on a list. And we'll talk about the two main organizations that handle this in the US and internationally. So on that list, what happens is they're doing already their immune panel to see whether there's a match, whether there's compatibility or not. And all this is done by computers today. So there are computer banks that hold the data of patients waiting for a transplant. And as soon as either a living donor shows up or a cadaveric donor, their organs or tissues are available, then that panel is done and matched with the recipient to see if there is a match or not. Okay, so a lot of background is done before, ahead of time of the actual transplant itself. So let's look at this issue of the immune rejection, because you can realize, okay, welcome. So you realize that when we receive an organ or a tissue from another body, right, even if it's a human body, the immune system is going to detect that as a foreign body and start attacking it. And of course, we want that to happen with bacteria and fungi and other foreign objects in our body, right? Other insults, but not with an organ transplant, because that's actually trying to save the life of the recipient. So as I mentioned, the immune system is toned down, and there's a lot of chemistry that goes into that. For example, they do serotyping to see the markers and the antigens of the recipient to try to make the match. The match typically doesn't have to be 100%, right? Because unless they're identical twins, monozygotic twins, it's not going to have a 100% match, right? But it's usually, I would say from 50, 60% match forward, it's okay, all right? The transplantation can be done. And then, of course, the immune system will be toned down on the recipient or the patient with the immunosuppressors. A typical immunosuppressor, for example, is prednisone. And for kidney, for example, which is the one I'm more familiar with, the match could be, the scale is 1 to 4, for example, and from a 2.5 forward, then that's a good enough match to go ahead with the transplantation. Typically, what they do is a PRA score, which is given in a percentage, really from 0 to 100% is the scale. And the PRA is a panel reaction antigens. And these are factors or proteins in the body that have been developed previously, again, focusing on the patient, on the person who needs the transplant, right, the recipient, to see if that person has been sensitized or not from either previous transplants or blood transfusion or something like that, or even pregnancy. Because again, going back to previous courses, the one on beginning of life issues, remember that the developing embryo or fetus is what percentage compatible with the mother? Genetically, what percentage compatible? 50%, right? Because the other 50% of the fetal genome comes from the father. So there's already a biochemical dialogue that is going on between the fetus and the mother. And so that is going to elicit some level of an immune reaction on the mother, especially at the beginning. Remember how the fetus, the early embryo has to convince basically biochemically the mother that it's a friend and not a foe so that the pregnancy may continue, right? Okay, so this issue of sensitization is important for the transplant situation so that the patient may have the best recipient, the best donor possible. And all that, like I mentioned, is done by the biochemical analysis is then put on computers at a national level. And there is 2 organizations that deal with that, one on the donor side and the other one on the recipient side, so that there's transparency and no conflict of interest, all right? So anyway, these, typo, antibodies can develop either from previous transplants or transfusions, or like I mentioned, the pregnancy. The higher the PRA score, the more sensitized that recipient is, okay? And so it limits their pool of donors because they have been sensitized already to some level. Speaking of transfusion, we can use a blood transfusion as an example to start looking at the issues of the immune rejection and compatibility. So the blood type, right? People know your blood type. We should all know our blood type. Sometimes it's put on the driver's license. And basically, for example, I know that I'm O negative, which is known as a universal donor, right? we'll look at that. It's a combination of 3 different proteins that determine our blood type. And those 3 different proteins are basically in 2 separate groups, the ABO group and then the RH factor, or RH antigen. So the ABO group is a classical 4 blood types, right? A or B or AB or O, which is actually, that O is actually a 0. So you people know your blood type? Anybody know your blood type? Yes, what is it? O positive, okay. O positive, no?
I do. I'm A positive.
Carolina?
I'm A positive.
A positive, okay.
Yes.
All right. Very good. So let's look at how that works. On the ABO group are 2 proteins involved, either A protein or B protein. All right. So the possible combinations are 4. This is on the RBC, by the way, on the red blood cell, and these are surface proteins. Okay. So an antigen basically is a protein or a factor on the surface of the RBC. And so if you are A, Carolina, then you have the A antigen on your RBCs only. A person who would be B, they have that B protein on the surface of the RBCs. But then both factors can occur simultaneously, and that person would be then a B person. This is on the genetics, right? Or if they lack either A or B protein, then they are 0 or O, right? That's why I mentioned that O is actually 0. So the 4 possibilities are either A, B, or O, right? So that's one group. The other group is the RH factor, which is known as RH positive or RH negative. That's a 3rd protein that is independent from the ABO group, all right? And the reason, anyone know why it's called RH? There's a hint right there in the photo. This is a rhesus macaque. It's a monkey in the old world, right? So it's a monkey from Asia. And there are 2 subgroups of these monkeys. One is in China and the other one is in India. But basically, they're known as old world monkeys. And for decades, they have been used in medical research because it turns out that their anatomy and physiology is fairly similar to the human, and their large populations, they're easy to maintain in lab situations and so forth. And their blood particularly is fairly similar to ours. And this factor was discovered in the rhesus monkey. It's a protein, it's a 3rd protein. It's not the A protein, it's not the B protein, it's the RH protein. So we either have that protein or not. And that's why it's called RH plus, RH positive or negative, all right? So some of you are positive, I'm negative, means that you have the RH protein and I don't on the surface of the RBCs, right? Okay, so that's how we come about. It used to be just the ABO group, but then this one is added, so now we have to add the plus or minus. And the best compatibility is, of course, with the best match, right? A little further, so the O type is known as universal donor. Why is that universal donor? Means that the O can give to the other 3 groups and also to O. Why do you think that is? Exactly, they don't have the surface proteins, either A or B, right? So the other 3 groups may accept O blood without causing an immune reaction. We're not talking about the RH factor, that's separate. The RH has to be compatible, of course, either positive or negative. And then, which would be the universal recipient that cannot donate to anyone else other than their own type? Exactly. AB can only donate to other AB, right? Because any of the other 3 types of blood, they're going to react negatively and mount the immune reaction, right? So that's how it's established. Then nature has also had a balancing act in this over hundreds of thousands of years of human evolution. So certainly way before blood transfusions, it turns out that what is the most common blood percentage-wise in any population? It happens to be O negative or O. right? So the most common type of blood is the universal donor. And that's a good thing, right? Because all blood types can only receive from all, see? But it's the most abundant by the numbers, so proportionally, okay? One last detail about blood transfusion, actually, remember how when we were talking about, about organs also, what is the only liquid organ in the body? Can I remember? The only liquid organ in the body is blood, right? So remember, cells with similar functions from tissues, tissues with similar functions from organs, right? And then organs with similar functions from the systems. So when you think about blood, it's got at least 3 different groups of cells. The RBCs for gas transport, then the white blood cells, which is a whole cluster of them for the immune system, platelets for healing, the scab and so forth. So really, blood is a group of tissues, but it's liquid because the serum component is mostly water, right? So blood is actually a liquid organ of the body. And so a blood transfusion, technically, it's an organ transplant. It's a liquid organ transplant, right? And the matching has to be done. Okay, back to then the solid organs. This is a list of people waiting for organs in the United States today on the transplant list, all right? It's about 100,000 for kidneys, it's the largest one. Liver, over 10,000. The heart, almost 4,000 people. Lungs, 1,500 almost. And pancreas, almost 1,000 people waiting for a transplant. Again, the one I'm most familiar with is the kidneys. It's interesting because it's the largest number of people waiting for a transplant, and about 15 die every day for not getting a transplant. All right. And but it also is the easiest one to remedy because it's the easiest living organ to donate. Donate one kidney if a person has good health and both kidneys are functioning fine. The person can donate one kidney and keep on living just like nothing happened. Well, there's a little bit of recovery, of course, after the surgery. All right. But so you can see that it's quite dramatic from the patient perspective. And typically these lists, anyone know how long it takes for these lists to kick in for the donor to appear, whether living or cadaveric? Yeah, several years, 1, 2, 3 years. Okay, a friend of mine had a heart transplant. He was on the waiting list for 10 years, 10 years for heart transplant. But it finally came through. He's from Colombia. His wife is from Mexico. And I mentioned Colombia because his heart was down to about a 10% functioning. They have a little condo, 2-story. And of course, the bedrooms are upstairs. So it would take him about half a day to come down the stairs and the other half a day to go back up the stairs. The heart was down to 10% functioning. And once he got the transplant, little recovery in about a month or so, he says, Father, look at what I can do. And with his cell phone, he started doing the cumbia, which is a very fast pace, you would know. If he had done that a month prior, he would have dropped dead, okay? So he was extremely happy that after 10 years of waiting and a heart pump and so forth to keep him going, finally he got the transplant. Of course, that was, the donor was what? Living or cadaveric? Cadaveric, right? Cadaveric, you pull out a living heart and you just kill the person. And who is the classical? I mean, this is sad, but it's real. The classical cadaveric organ donor. That's one, or motorcycle rider in their 20s, because the motorcycle stops and the rider keeps flying until they hit the asphalt or the concrete, and right. So it's tragic, but that's the most typical cadaveric donor. Yes, Chris.
Are there any quality of life changes for donors who give away one kidney?
Right, so I can speak to that toward the end of the lecture because I happen to have donated a kidney about 15 years ago, and here I am still taking and cutting down trees in the forest and stuff. So my quality of life essentially has remained the same. It's anybody's guess if it was diminished or not, because I would never know how long I would have lived with two kidneys. Of course, the danger is that if I get like an infection or a renal disease, then I only have one left, right? As opposed to a pair that would, but typically when kidneys fail, they fail in pairs, you know, on average. But, and also it's a whole issue that the fact that I may at some point develop renal failure doesn't mean that necessarily I have to die. I can also apply for, I get on the list, right? And maybe a parishioner who have mercy on me or something. But yeah, we can talk about living organ in a little bit. It's exciting that that 100,000 people on the list could actually be wiped out, because when you consider, even though in absolute numbers, the numbers are dramatic, relatively speaking, when we put it in context of 330 million people in the United States, these numbers are really percentage-wise, they're very small. So as far as living donation is concerned, you know, altruistic people can actually do a lot about diminishing these numbers if they only had more information and knew a little better what's involved about a living organ donation. Because again, of these 5, kidney, liver, and lung can be donated while living and keep on living, right? The heart, actually, there's one way of donating a living heart, but it's a little complicated. We'll look at it in a minute. Let's look at the 2 organizations that manage this organ donation, because you can see they're high stakes for people who are on the transplant list waiting for donation. Sometimes, you know, not everyone has the same ethics and value system that we may have. And some people may be on that list that are unscrupulous, and they happen to have resources and money, so they'd be willing to pay for organs to get them and keep on living, right? So it could be ethical issues come up. And so to manage all that, in the 1980s, Congress developed an act, crafted an act, which is essentially a law that regulates all of the organ donation and organ transplants in the US, all right? And it's called the National Organ Transplant Act, NOTA for short. And it's a federal regulation of organ transplantation in the United States, organ and tissue. And so basically there are 2 agencies under NOTA, one for the recipient and another one for the donor, okay? So the Organ Procurement Transplantation Network, known as OPTN, is the one that receives the organ, but I put receive in quotation because they don't physically receive the organ, you know, in a box or in ice or anything like that. What they receive is the data, the panel, the PRA score and stuff like that, all right? So they have essentially data banks in a computer system where the whole registries of names of individuals and their PRA score and all their panel waiting to make a match. And then the other organization that is in charge of allocating the organ, this would be on the donor side, right? That's called UNOS. It's the United Network for Organ Sharing, UNOS, all right? So basically, UNOS is the data bank that is registering donors, whether living or cadaveric, and have all the panels, the PRA scores and all that to make the match with OPTN to find a recipient, a matching recipient. Of course, the largest registry is going to be on which side, do you think? By the numbers. The largest registry, is it going to be on UNOS or OPTN? who is the one with the needs? The patient who is on the waiting list, right? So OPTN is the one that has the largest list of patients waiting for the transplant, essentially these people here, all right? That would be on OPTN. See, they are the ones that have the registry of recipients who are waiting, of patients who are waiting for a transplant. And then the UNOS is a very dynamic system. It's constantly being updated either with living donors or cadaveric. As soon as a person dies and they have it on their license or stated elsewhere that they want to be organ donors, then right away, the organ transplant team will come in, take the blood samples that are needed for doing the PRA scores and pump it into UNOS to start looking for the match. Okay, so that's the background that I was talking about, that it's all computerized at the national level, and it's overseen and supervised by NOTA, by this act of Congress, so that it's all transparent and clean, so that there are no conflict of interest there and no one is paying for organs or making other promises and stuff like that, okay? All right, so of course it's understood that each organ has specific criteria for either allocation and for the transplantation itself, right? And the transplant team will know about all that, all those details. Now, there's an alternative to getting on the waiting list, and this is known as targeted donation. Target donations are when the patient finds a donor that will donate to them specifically, all right? And that's called a target donation. In my case, for example, it was a parishioner that I knew back at a parish where I was pastor in the 90s, and I know that this patient had a very complicated medical history. She had had a stroke and was already on kidney failure. She had had 2 transplants already, 2 kidney transplants, cadaveric both. The first one lasted about 15 years, and the second one lasted maybe about 4 or 5 years, because the second one, from the start, she had difficulty with that second kidney, and right away started on immune rejection, and little by little, that second transplant, the kidney died, and she went on renal failure, so she was on the dialysis machine, right? And so I knew that she wouldn't qualify for a 3rd transplant because she had had 2 already. So the way to bypass the list is to do a target donation, all right? And I did the PRA scores and all that. It was here at Jackson Hospital, which is the transplant center for Dade County, and did the panel reaction and all that to see if there was a match, even before I said anything, because there's no sense telling the person and getting them all enthused about, you know, getting a vital organ, and then it turns out there's no match. So I asked Jackson if they would do the match anonymously to see if there was a match, because they had all her information from the previous transplants, and they said, yes, we can do that. So we went ahead, and once they told me that there was a match, and that's how I know the 2.5, because it was a 2.5 match over 4, all right? It says, it's not perfect, but it's a good match, good enough to go forward. Then I proceeded to ask her if she wanted and so forth. And then eventually we did the transplant. That's about 2007. So it's been about 14 years. And we're both still living fine, you know. And of course, it didn't take away the stroke or any other issues that she had on her medical history, you know. But as far as the donor is concerned, here I am. So it's a living proof that it does work. Of course, you got to be healthy, right? Because they're not going to make a healthy person ill by extracting a vital organ. But if the person is actually healthy, then it can be done. All right, so target donation bypasses the transplant list is what I wanted to get to.
Will you talk about what are the things they look for when they look for match?
Yes, okay, so obviously the blood type is one, that's a very important one, but then other antigens and that whole PRA score, it gets very technical. There are dozens of antigens or factors, basically they're proteins that are in the body, in the circulatory system or in different organs, and then the kidney specifically, proteins that are specific to the kidney, right? To see if the match is good enough. What's interesting about this case is that her mother was willing to donate a kidney, but the mother was not a match. And I, who have no relation to her, as far as we know, we're not related anywhere, I was a match. And so, this whole thing of the matching is very interesting, how they can do this. And again, the living proof that it works is that we're both alive. So, yeah, well, might as well, since it came up, I might as well say that, no, let me hold on that. I want to cover a little more grounds before I give a couple more details for the living organ donation. All right, so basically targeted donation bypasses the transplant list, but that's in the United States because we have a market economy and basically a commercialized healthcare system. But in other countries, a target donation is accepted, but they still have to go on the list. So it doesn't bypass the list necessarily. And typically that happens with socialized medicine. So that's another down side of socialized medicine, that because it focuses on public health and so forth, they'll take it like a living donor, right? But that living donation has to go to the pool of the people who are waiting for a transplant. So they'll make the match with the pool, and therefore one can donate, but it doesn't necessarily bypass the list, okay? And Europe is an example of that because they have mostly socialized medicine, different styles. Chris?
So if I chose to donate my kidney to a friend of mine, and we were both in Europe,
Right.
it might not get to my friend.
That's right. That's right. What it would do is it would go to the pool of patients who are on the list, but it would move the patients up, because then some patient would get your kidney and then your friend would move up on the list wherever he was. You see, so it does help him, but it helps him indirectly. All right, not directly.
Can I choose to reject the individual that would be getting my kidney, or?
Well, you can refuse to donate, even last minute before they give you the anesthesia, but you cannot choose where it's going to go to. Yeah, because then that may be considered prejudicial and so forth. It's just a different philosophy of medicine when we talk about socialized medicine. What takes priority in socialized medicines, by far, is just the public health. It's the group as opposed to the individual. However, there's a way of bypassing these two issues, or the impasse, let's say, between market economy medicine or socialized medicine, which is known as domino transplants, okay, domino transplants. And it's a creative idea that the medical system have come up with to try to bypass that impasse between target donation or not target donation. So let me show you what that means. Domino transplants. Domino transplants involves more than one donor and one recipient, okay? The simplest one is 2 donors and 2 recipients, where there's a pair exchange. There are different types. Some can be the heart-lung, but the most common one, again, is kidney. Let's look at heart-lung first, because it's an exciting way of actually transplanting a living heart, okay, or a heart from a living donor. It's unique. And it has to do specifically with cystic fibrosis. CF is a genetic disease of the glands and the tissues that make mucus in the body, mostly on the lungs, but other parts of the body, the digestive system, and so forth. And so normally, these glands and tissues that make mucus in our body, for example, mucus from the nose, is thin and runny. The mucus itself is thin and runny, and it serves as a lubricant and as an antibacterial and antifungal and all that. But in CF, in cystic fibrosis, the mucus is thick and starts to solidify. And so instead of facilitating the metabolism of the body, it actually clogs it up, all right? And so people with cystic fibrosis have a limited lifespan, and they have, it's progressive and degenerative, as we say. To date, there's no cure for it, even though there's some medication that helps to dilute the mucus a little bit. So it expands their life a little bit, but they usually don't go past 30 or 40 years of age, you know, to kind of half the lifespan of a normal human being, which is in the high 70s or 80. So particularly for the lungs, because it develops thick mucus in the lung and they have more and more difficulty breathing, right? It occludes the alveoli in the lungs. And so basically what cystic fibrosis patients need is a new set of lungs, right? But they need both lungs, or actually all 5 lungs. You know, we have lobes in the lungs. We have 3 lobes on the right lung and 2 lobes on the left lung, all right? So we actually have 5 lobes. For CF patients, they need all 5 lobes. They need the full 2 lungs. So obviously that has to be what kind of donation, living or cadaveric? Cadaveric donation, right? Because they need both lungs, okay? And of course, for the match of the deceased person. It turns out that by reasons of anatomy, it's easier to transplant the lungs and the heart together rather than just the lungs because of the human anatomy or the anatomy of mammals in general. So let's look at that for a moment. So here's a circulation, and it's known as a double circulation. I don't know if you've heard of the left heart or the right heart, right? But there are 2 double circulations. There's a double circulation anatomically, and there's a double circulation physiologically. Anatomically is what is known as the pulmonary circulation and the systemic circulation. So pulmonary circulation is from the heart to the lungs and back to the heart, right? Whereas systemic circulation is going to be from the heart to the rest of the body, back to the heart, all right? And actually this way. So systemic circulation is to all the capillaries of the body. And that's going to bring oxygenated blood through arteries into our tissues. And then through capillaries, the RBCs that are carrying the oxygen are going to release the oxygen and pick up what? From cells. Product of metabolism, CO2, right? And then that becomes venous blood, which is CO2 blood. That's why it's represented in a blue or purplish color. And then that's going to go through the veins. And the biggest vein is the vena cava, right? Into the right heart. Then the right heart is going to pump that venous blood to the lungs for the other exchange. So in the lungs, we have the opposite exchange. Venous blood is going to release CO2 and pick up oxygen. So in the lungs, the blood becomes oxygenated, right? And then that oxygenated blood, the red blood, is going to come back into the left lung, into the left heart, sorry, to be pumped to the systemic circulation, right? So you have 2 circulations, and there's a wall in between, literally a wall, the septum of the heart, that separates those 2 circulations. So we have 2 independent circulations at the level of the heart. They match up at the level of the capillaries, whether it's the systemic capillary, systemic meaning from the system, from all of the organs and tissues of the body, or the pulmonary capillaries, right? The alveoli. So another way to remember this also is that arteries go out of the heart and veins come into the heart. Think of arteries and veins in the capital letter. So capital A looks like an arrow going out. So arteries go out of the heart. Veins, the V is an arrow in. So veins come into the heart, all right? Because the type of blood will change depending if it's pulmonary blood or systemic blood, all right? So for example, the aorta, is it an artery or a vein? The aorta is an artery and it comes out of the heart, okay? And the aorta is the largest artery. Actually, the diameter of the aorta is like a dime, okay? It's the thickest. That's why a rupture of the aorta, within a minute or two, that person is going to bleed to death because you see the squirts of blood coming out fast, all right? So arteries come out of the heart. Let's look at systemic circulation first. And that is going to be oxygenated blood. That's why it's represented in red out of the aorta. And then it's going to branch out the arterial blood, arterial circulation into all the organs and tissues of our body down to the capillary system. Capillaries themselves are microscopic because they only allow a single RBC at a time, which is a diameter, I'm going to guess around 10 or 15 microns, all right? And so the capillaries are microscopic and only one RBC at a time goes through because in that going through, that's when they exchange the gas. They release the CO, they release the oxygen into the tissue and they pick up CO2 from the tissue, right? And now blood that is leaving capillaries and going back to the heart, now that's venous blood that has CO2 in it and not oxygen. So that's going to go through veins. Again, I mentioned the vena cava. There's anterior and posterior vena cava coming into the heart, now into the right heart, which is venous blood. Veins come into the heart. Now that blood, that venous blood, is CO2. So let's say we can call it from the gas perspective, it's toxic blood, it's not oxygenated blood, right? We need to get rid of the CO2. Now we go into the pulmonary circulation. And here is where the names switch, or rather the blood quality switches. Arteries always come out of the heart, right? So the pulmonary artery comes out of the heart and goes to the pulmon, the lungs. But that's carrying venous blood, that's carrying CO2 blood. And that's why this is an artery that is carrying CO2 blood. Okay, normally we associate arteries with oxygen blood. That's because we're talking about the systemic circulation. But in the pulmonary circulation, arteries carry CO2 blood. Then at the lungs, the gas exchange occurs, toxic goes out, CO2 goes out, oxygen comes in, and now we have oxygen-rich blood returning to the heart, but because this blood is coming into the heart, it's coming in through veins. So that's the pulmonary vein. Okay, so it's true that arteries carry oxygen blood, but only in the systemic circulation. In the pulmonary circulation, veins are carrying the oxygenated blood because they're coming back into the heart. All right, so details. Now, let's look at the transplant, the lung transplant. Yeah.
What exchange of gases happens in the lungs so that it turns?
Yeah, exactly. Well, you think about it. What is toxic? What is a toxic gas? CO2 goes out, and what is picked up? Oxygen. And at the level of the RBC, remember the molecule that holds that is the transport, the gas transport. It's a molecule complex that has an iron atom in the center. Hemoglobin, exactly. The hemoglobin, which is made up of 4 subgroups of 4 myoglobins together, right? And the center is an atom of ferrum, of iron. And that's why iron in the blood, if people have low RBCs, they are anemic and they feel tired. They're not getting enough oxygen. Right? That's the combination, that's the match. All right. And also, why does blood look red? What gives blood the reddish color is precisely what happens to iron when it oxidizes. Iron rust is what color? Brown, reddish is, so iron when it rusts, it's an orangey brown color, all right? But if it were pure iron, it would be a little more reddish, more orange reddish. So what makes the blood red is the oxidized iron. How do we oxidize iron? Iron oxide, FeO2. You see, so rusting the blood, oxygenated blood is rusted blood. The iron is oxidized, right? FeO2, which is that rusty red, rusty orange, but with all the other factors and the serum, which is kind of an amber color and so forth, the overall color at the naked eye is a reddish color of the blood. When it's lacking the oxygen, then now iron, instead of oxygen, has CO2. Now it's FeCO2. It doesn't look as red. It's not technically as oxidized. Okay, so it looks more bluish. And in fact, when we get, sometimes we get our fingernails, bluish fingernails, right? When it's very cold, that also means that we have more CO2 in our blood than normal when it gets very cold. Hypothermia, we're losing oxygen in the blood. So the exchange, the gas exchange at the lungs is vital for staying alive, and that's the function of the lungs. At the level of the tissue is the alveoli, right? And precisely, there's a mucus that covers the alveoli so that it keeps the alveoli in a watery system, because this exchange at the cellular level is a water exchange, it's a liquid exchange. So the lungs that are exposed to air, they're not directly exposed to air, they have a thin layer of mucus that makes the lungs themselves be in a liquid environment. And that's the mucus that fails in cystic fibrosis. It becomes thick, so it clogs up the alveoli. And these people can breathe less and less and less, all right? So it's very debilitating. So what happens for a lung transplant, if it was only lung, all right, for the recipient, they would have to, cut the pulmonary arteries and veins and extract the lungs. But then there's the other irrigation of the lungs themselves, of all the other capillaries that keep the lung tissue actually alive. Instead, so in cystic fibrosis patients, it's also important to know that the heart is unaffected because the heart doesn't have any mucus inside or out. All right, so the heart is unaffected by cystic fibrosis. It's a condition that affects the lungs and some of the intestines, but not the heart. So from a CF patient, the heart may be healthy and intact. But for models of surgery, it's easier to keep the heart and lung together so that the pulmonary circulation is not compromised. Instead, what they cut is the aorta and the vena cava. And they keep this whole complex, they keep the pulmonary circulation intact. And what they cut on the cadaver, right, is the aorta and the vena cava, which excludes the systemic circulation, which is the larger circulation, right, to the body. But that's basically just two large blood vessels, artery and vein, which are very easy to anastomose. Anastomosis is to sew back together with a very thin curved needle, and typically gut nylon or something like that, or biodegradable nylon, to sew back. Literally, they have to put it back together, right? The tissue. And so the larger that artery or vein is, the easier it is to anastomose around it. So for purposes of surgery, it's easier to keep the heart-lung circulation intact as a single package, right? On the recipient side also, on the patient side, what needs to get out, what's diseased, is the lungs. So again, they take out the heart, the lungs, and the heart of the patient. The lungs are bad, are cystic fibrosis, but the heart is okay, it's intact. So the heart can go to a heart transplant patient, and they're getting a living heart, which is higher quality than a cadaveric heart. Because no matter how long, even if it takes just an hour or two to do, imagine a heart transplant in 1 or 2 hours, you know, that heart has been sitting on a counter for 1 or 2 hours, okay? So that's the one case where in cystic fibrosis, a second patient, which is a heart patient, can actually get a living heart. And what the recipient gave was living organs to 2 different patients. Gave the lungs to one patient, to a cystic fibrosis patient, and gave his or her heart to a heart transplant patient. Hmm?
So
yeah,
2 donors, 2 recipients. The first,
one donor.
oh, 1 donor.
Well, sorry, I take it back. You're right. Technically, 2 donors and 2 recipients, but 1 donor or recipient are the same. Think of it in the middle. Start with 1 donor, cadaveric, heart and lung intact, into the CF patient. The CF patient gets the lung that they need, but they donate out a bad lung and a good heart, which goes to the heart recipient alone. Right? So yeah, 4 donors, but actually 3 people. Creative, right? So really, it depends on what is the condition, what is the need, and so forth. It's very organ or tissue specific, right? It begs the question. All right, so even more creative is the abdominal kidneys for a number of reasons. Again, first of all, because they can be living instead of cadaveric, but also because, well, it's the greatest need just by the numbers, 100,000 just in the US, and the easiest also to transplant because it can also be done laparoscopically. Laparoscopic transplantation is a minimal invasive surgery. I don't know if you heard of the Da Vinci, not the Da Vinci Code or paintings, but surgery. Yeah, it looks like an octopus. It's a robotic. Look at this guy. Okay, that's the Da Vinci. It looks like an octopus actually, and it's a robot that is doing the operation. And the technician is inside a computer system with a joystick or 2 joysticks manipulating. And this is actually more accurate. It's another version and the team. All right. And here it is, ready to go to action. Oh, bigger. There. Interesting, huh? Surgical room, relatively easy to sterilize all this because there are no human beings in here. And typically it's 3 or 4. What they do is with one system, they make three incisions. Actually the 4th incision is at the end. One incision will be a tube to expand the cavity, the abdominal cavity with gas, which is typically CO2, all right? So it expands the abdominal cavity. They generate like a dome inside the abdominal cavity. I'm talking about kidney specifically. And then through that tube also there's a camera so that the person behind the scene there can see right on a screen inside the abdominal cavity. Then that camera also has a lens that magnifies typically about 10 times. So what is microscopic to the eye becomes 10 times larger. And the macro manipulators, this machine is so sophisticated, it's $1 million machine, but it's so sophisticated that it will move microns, you know, with the joysticks that the surgeon is using. So it's much more precise and accurate than a human scalpel cutting a human being with a scalpel opening up, all right? And then you can leave the machine there. In fact, they've gotten so creative that the scalpel is a wave, it's a vibration, it's an ultrasound wave. And the ultrasound wave cuts the tissue and at the same time, at the back end, cauterizes, seals it together again with heat. It's amazing. So it's minimal blood spill, right? Because at the same time that the ultrasound is cutting tissue, it's also healing it at the back end, right? So it only cuts where it needs to cut, and it's minimal blood loss. Then through another one of these arms, the surgeon will put the scalpel, the cauterizing, the cutting, the ultrasound machine, right? And that's how they work it. So they have cameras, they have a dome generated there, and most of it is cutting through scar tissue and all that until they finally liberate, isolate the kidney. And now they're ready to extract the kidney. And that's the last surgery that is done, and that has to be done physically, and that's the fourth incision. And typically what they do is they do a inverted U around the navel. Around the navel, they do an inverted U cut, right? Because that's an access into the abdominal cavity. And that U-shaped cut, inverted U, only needs to be as large as the hand of the surgeon that is physically reaching in to pull out the kidney. Okay. And again, talking from experience, so there are three teams of surgeons. One team of surgeons is working on the recipient, preparing the patient, the recipient, to receive the kidney. The other, now on the recipient side, of course, it has to be the traditional surgery of opening up the abdominal cavity, because they need access to physically install, which, by the way, they don't install, our kidneys way up here, just underneath the rib cage in the back, but they don't put it back up there. They just place it at the abdominal cavity, kind of near the bladder, because it's a short distance from the bladder, from the transplanted kidney to the bladder itself, the ureter, to empty into the bladder. And so it's in that region of the abdominal cavity, low region on the recipient side, but that has to be done with a classical traditional open surgery. On the recipient side, what I'm saying, on the donor, it can be laparoscopic. And then, so there'll be another team of surgeons over here on the donor. And then the third surgeon is the one that physically transports the kidney from one operating room to the other one. And these two theaters typically are next to each other physically. Under two rooms, two ORs, operating rooms, that are next to each other, connected by a door. And the third transplant surgeon literally walks the kidney from one OR to the other one, okay? But I mentioned about this thing has been so specialized and so perfected that the surgeon on the donor, okay, can be a woman, and they prefer to be a woman because generally they have smaller hands. And the one who was on me, on the donor, her name is Dr. Chan, and she is Chinese Jamaican. And she has very small hands. So that incision is the minimal incision just for her hand to literally fit in there. So you can imagine the level of detail of perfection that they have done with this surgery to encourage, living donors and so forth, because it's really is minimally invasive. And it depends if it's the right kidney or the left kidney. They do some previous work, the workup, including a scan of the abdominal region to visualize the kidneys through MRI and to see which kidney qualifies, all right? So if it's the left, one of the two kidneys is behind the liver, I forget which one it is, but if it's not behind the liver, then that one qualifies for laparoscopic. Which kidney, I should know, but I forget. Which kidney is behind the liver? Let's see, the right kidney. Posterior to the liver, right. Okay, so if it's the left kidney that qualifies for the transplant, they can do it laparoscopically, all right? If it's not the left kidney, if it's the right kidney, then they have to do it with traditional surgery because they literally have to move the liver aside to get to the kidney. It's posterior, it's behind. And they come in from the abdominal region, they don't come in from the back. So if it's the left kidney that qualifies, they can do it laparoscopically. And so that was the advantage. Bottom line is, for me, it was only 3 incisions, a small hole, which are much easier to seal, and then that cut around the navel, and all that heals. And the hardest part on the recovery side, I was like 2 days in the hospital, then they kicked me out, and I was at home for another 5 more days, more or less, and then resume normal life, right? At first, you don't want to lift heavy things and stuff like that too much, but you'll see, you pace yourself, and within a week or 2, you recover your normal life. The thing that was longest, that took longest, that I still felt pain and discomfort in the stomach region, in the abdominal region, was actually the CO2 gas. Now, they tried to suck out at the end of the surgery, once they're done, talking about the donor, with the same tube that they inserted the CO2 to make that dome, right? From that same tube, they suck out CO2, but they don't suck out all of the CO2 because they could suck out some tissue in there. So they leave a little bit of CO2 inside the abdominal region. And of course, the abdominal region is not used to having CO2 gas in it, right? So it feels like you have gas, and you need to pass the gas, all right? But it has to go through the tissue, and it passes passively. The tissue reabsorbs that CO2 and passes it systemically through the blood system, and it takes a while. So in the meantime, there's that discomfort / pain. It feels like one has gas and you can't pass it. You know? So it's a discomfort, and that took about a week and a half, maybe up to 2 weeks, and it was diminishing. I can tell that it was getting low. At first, it was pretty uncomfortable. So they say walk and drink a lot of water and so forth to try to stimulate the abdominal region to absorb all that CO2. But that was basically the extent of it. And when one figures out, when one sort of equates the discomfort and the pain and the trouble and the bother that the donor goes through, right, for donating a kidney, on the side of the recipient, basically, you've given a new life to that recipient. The recipient gets a life, because if the donor can live with 1 kidney, the recipient can live with 1 kidney. Of course, they have to be on immunosuppressors, right, which tones down the immune system. But then, being prudent about life, they can have a normal life. Chris?
How long do we have to stay on the immunosuppressants?
For life, generally. For life, yeah, because exactly, at any time, that's still a foreign tissue in there. You know, it's still a foreign organ. The DNA doesn't change. It's still the cells from the donor. So they have to stay on immunosuppressants for life. But they tone it down and they take it to the minimal. And then these people typically once every 2 or 3 months go to the transplant center for blood analysis, right? And they're monitoring all the immune system and all the antigens and the proteins. So they're monitored for life. And yeah, that's the way it works. Okay, so abdominal kidneys have become very, it's an original way to do this. And this is how it works. The simplest one is what is known as paired exchange, pair exchange. Let me see. It's okay, how about we're gonna take a break. Well, let's see, we don't have too many. Yeah, okay, let's take a break after the pair exchange since we're in the midst of it, all right? So this is how it works. You have a donor and a recipient, and the donor is a living donor. We're talking about kidney specifically, but they are not a match. They're not a match. So say you have a friend or a family member who is on kidney failure, you know, renal failure, they're already on dialysis. You want to donate, but you're not a match. So we cannot change the biology, but we can get creative. We find a second pair of donor recipient, they're not a match either. But their donor is a match with your recipient, and you as donor are a match with their recipient. Okay, so it goes across. And that's basically the paired exchange. We got the donor recipient pair 1 and donor recipient pair 2. They're not matches to themselves, to each other, but they are cross match. So the donor 1 is a match with recipient 2, and donor 2 is a match with recipient 1. That's the pair exchange. Now you see how useful is that UNOS and OPTN, because this can happen at the national level. They don't all have to live in the same town. These 4 people can actually live in 4 different cities of the US. And they need to come together. Typically, they come together to where the recipient is. Okay, so donor 1 needs to fly to where recipient 2 is. And donor 2 needs to fly to where recipient 1 is. Okay, and the system needs to be so transparent that there's no exchange of money. I happened to be living in Philadelphia at the time, and I had to pay for my own ticket round trip to Miami. So that there's transparency and there's no perception, the minimal perception that there's going to be, a money exchange. So the recipient wasn't even allowed to pay for my ticket. All right. So that's how they keep it. All right. So of course, it doesn't prevent a donor from receiving donations from other people or family and friends and so forth. But again, it has to be very clear that they're not paying for that kidney. All right. If there is some suspicion that the donor is getting paid for the kidney or whatever organ, everything stops right there, because it's a conflict of interest and it compromises the whole surgery. Okay. All right, so that's how it's worked. And the simplest one, like I say, is just 2 pairs, right? The most complicated one to date is 60 transplants, 30 pairs, 30 pairs. This was done in 2012 here in the US, and it involved 60 kidneys going back and forth, all right, or 30 donors and 30 recipients. It involved 17 hospitals, 11 US states, and 4 months to accomplish the whole thing. Yeah, but it started with one guy who was in a yoga class or somewhere, and a stranger told them if they would like to donate a kidney. Just a conversation that happened, all right? This is the guy who started it. Rick Zuramenti was the first donor, okay? So he donated. So this other fellow obviously knew someone who needed a kidney and was just asking around, would you consider donating a kidney? It's just straight up, you're having a good day. And this guy, Rick, thought about it and said, well, why not? Maybe he had taken a course like this or something. I said, why not? And so that started it all. All the other 59 people were lined up already at UNOS and OPTN waiting for the right match to click in. And so 4 months later, everybody had gotten their kidney and had donated their kidney and so forth. And at one point, the thing almost fell through, ran aground, because you can think about it. Okay, it's a stepwise. Obviously, the recipient is getting the kidney of the donor before the friend of the donor is getting that other kidney. And so it could happen. The possible scenario is that once a recipient receives their kidney, their intended donor, their targeted donor says, okay, I'm out because my recipient already got his or her kidney, so I'm not going to donate. And that would truncate the chain, right? If the targeted donor decides, well, my recipient already got the kidney, so we're out of here. I don't have to donate anymore. It's an ethical thing, of course, but it breaks the whole chain. And it almost happened in this case. It almost happened, but family and friends and doctors were able to convince the targeted recipient to go through, please, and to follow through with the altruism. Otherwise, they were going to leave this number of people dead. You know, they are already committed, so follow through with the commitment, right? I mean, they cannot be forced. Obviously, they're going to be chained down to the surgical table, right? But they were convinced to follow through and do the right thing, right? There's a link there if you want to read more details about it, but I thought it was fascinating. I ran across it, and to date, this is the most sophisticated one that they've done. Mm-hmm. Another detail on the donor side, it's all for free. On the recipient side, typically insurance picks it up, all right? And that insurance includes the donor surgery and post-op and all that. And they also follow the donor, at least here in Miami, they follow the donor for a whole year for free. Once a month, I would have to go into Jackson to have blood work and so forth to make sure, you know, at first the blood pressure rises a little bit because the kidneys are osmoregulators. How do they regulate the water in the blood, right? Because they need to take out the toxins, and those toxins, urea and so forth, ammonia, they're mixed in the water. And so that's how we urinate the toxins. And by taking out water from the blood, that raises the blood pressure, right? So kidneys are osmoregulators, and they have to do with blood pressure, which brings me to the point that for the donor has to have good blood pressure. You know, you cannot have high blood pressure. It doesn't qualify you for donor if you have high blood pressure. But then what happens is the other kidney compensates. The sole kidney, the solitary kidney, as they call it, compensates for the missing partner. And it actually grows a little bit. The solitary kidney over time grows a little bit. The other kidney, I joke because every now and then with my urologist, he always, when I have my checkup, my annual checkup, he always does an ultrasound, right? And on the technician, when I go to the technician and the technician is looking for the other kidney, right? And there's nothing there. So they have to document that. And I always ask them, just for joking, but I ask a very straight face, is it growing back yet? Is it growing? You see it yet? You see it growing back? It doesn't happen, you know. But yes, the solitary kidney on the donor grows a little bit to compensate. Okay, what else? Yeah, so we're basically down to now a number of bioethical questions. Oh yeah, well, the last thing on the living donor, and this applies not just to kidney, but to any, also for lung and liver. So let's talk a little bit about lung and liver. For liver, you know, we have two lobes of the liver, one larger, the other one smaller, but the liver regenerates. It has a lot of stem cell in it, and you can section out a part of the liver and it will regenerate. Okay, so the liver is one of the organs that regenerates the most. And so one could donate a lobe of the liver and keep on living, and that one does regenerate to some extent. And of course, this recipient can live with one lobe. Then the lung also, I mentioned that we actually have 5 lobes, right? The right lung has 3 lobes, and then the left lung has 2 lobes. So a recipient, say, for example, emphysema or something like that, they can live with 2 lobes. They're not going to run the mile. They're not going to be athletic or do a marathon, right? They can live a very sedentary life, but they can live with 2 lobes of the lung, minimal. And one can donate if it's going to be, of course, if it's cadaveric, they can have both lungs, all 5 lobes. But if it's going to be a living donation, one can donate 1 lobe and still keep 4 and keep on living. And that basically, quality of life remains essentially the same with 4 lobes. 4 lobes is okay, all right? So for a lung recipient, for a lung patient who is in need of lungs, they need to find 2 donors. If it's going to be living, they need 2 living donors because they need a lobe from each, right? In other words, they will only transplant, the surgeons, the medical professional will only, from a living donor of lung, they would only transplant out 1 lung, 1 lobe to not compromise the quality of life of the donor. So that one needs two donors. the living lung donor. And I mentioned, so the fact that one wants to donate is not sufficient. One needs to qualify medically, physically. And so one needs to get clearance. And clearance from the general doctor, the general practitioner, right? But also clearance from the specialist. So in my case, for example, I needed clearance from the nephrologist, who is a specialist in kidneys. And I also needed clearance from the urologist, right? Which is associated with kidneys. In fact, I had even had a kidney stone way back when I entered the seminary. I was in my late 20s. It must have been, yeah, at least 25 years prior. I had had a kidney stone and I passed it, but it was the only one I had. It was not recurring. And even that did not disqualify me. So it's really interesting how specific they are, you know, how accurate they are. So they need clearance, and including mental clearance, meaning that I also had to meet with a psychologist. I don't know if there was a psychologist or a psychiatrist, but it was a mental doctor. And the key question is, well, what happens? How are you going to feel when the transplant goes through, right? And then in a week or a month or a year, your recipient goes on kidney failure on your kidney. You know, the donation that you gave, now they're on renal failure and that kidney is shut down, you know, and they're dying even after you gave them the kidney. How are you going to feel about that? Right? And well, if I say, oh no, oh, that's horrible, that's a tragedy, I'm going to jump out the window, then obviously that's not going to qualify me. I said, well, doctor, first of all, I'm a priest, so I take it in context. You know, I tried, I did my best, it didn't work. Well, so be it. Frankly, I know that we're not here for eternity, so sooner or later that same death is going to come to me too. So what if my kidney fails and it's not her kidney, or is it not the one that I gave, but the one that I have? You know, that's another question. What if your kidney now fails? What do you do? So they want to make sure that the person is stable enough to donate, you know, and go forward. But they need, you need clearance also from mental health doctor. All right, it's very, very thorough, and that's a good thing because they have the best interest of both the donor and the recipient. And for cadaveric donors, of course, they typically is brain death. And what they do is they support the organs, the vital organs, with a ventilator, and they heparinize the blood, for example. I'm talking about cadaveric donor now, a person who has tragically died, typically from a brain concussion, but from the neck down, he or she is intact, right? And so if they are blood donors, it appears on the license, or the next of kin says, yes, they want to donate, or the proxy consents on their behalf, right? Because now it's a cadaver. Then they put them on a vent to keep the lungs going artificially and oxygenating the blood. And then they heparinize the blood, meaning that it will not clot, right? But we have a cadaver whose vital organs are still living. All right, and we have to be very clear about that clinically and bioethically. That's why the declaration of death is crucial. The declaration of death is also a legal document. It's a medical document and a legal document. And when the doctor says this person is dead, we no longer have a person. Well, now we have a cadaver. All right, and brain death, that's why brain death, we want total brain death, including the brain stem. So the person may actually be declared dead. And then it's ethical to go in and pull out the vital organs, including the heart and the liver and the lungs, because if the person was not really dead, that's going to kill him. All right, and we may not kill any innocent person.
On average, how long do the organs still function? You have to remove them.
Exactly. It goes organ by organ. Every organ starts taking a hit the minute that the person dies, okay? Because what happens is with the nervous system, there is loss of integrity, right? The loss of integrity. And so the support system, basically you can think of from the neck down, it's a support system for the brain, for the brain and the brain stem, right? especially circulation for blood and oxygen and so forth. But from the neck down, then it depends on what organ or what system we're talking about. Different organs and systems last longer or less. The heart is one that lasts very little. The lungs without air inside literally will collapse, right? So that's one of the reasons for the vent is to keep the lungs inflated. The kidneys last longer. Glands, pancreas, thymus, I don't know exactly, but it's within hours. The window is generally within hours, like from half an hour to 24 hours. And literally these organs are actually transplanted in ice and not dry ice, not dry ice because dry ice is very cold, it's too cold, but just regular ice. What they do is they put the organ inside a sterile bag, and then that plastic bag is surrounded with ice in a cooler, and the guy goes, or the person goes fast walking to the next station to hand it over, all right? But it's literally transported in ice to, what's the reason for the ice? So it's regular, normal ice. What does ice do physically? Lowers the temperature. By lowering the temperature, you lower the metabolism, right? So there's less circulation and everything slows down. It's kind of dormant. You're trying to put that organ into dormant, especially the heart is a typical one that is transported just in a cooler from one place to another. Yeah, so there are many, many more details, of course, to all this process. Finally, we can look at some other bioethical issues. There's a whole constellation of bioethical issues that surround it, right? For example, the determination of death. Again, whether it's the classical determination of death of no heartbeat and no breathing, or typically it's the neurological because they're looking for vital organs from the neck down. So there's no brain transplant to date yet, right? So it's typically the vital organs are going to be from the brain down, from the neck down. And so the determination of brain death is very important. That is total brain death. By the way, speaking of that, I've been transgressing all over the place today, but basically when I was studying in Rome for the first doctorate, one of my professors had written an article. You'll hear about brain transplant, right, or head transplant. Theoretically, hypothetically, I mean, the surgery can be done, but there are a lot of ethical issues involving that, okay? But his case was, is it really a brain transplant, a head transplant, or is it a body transplant? Because the seat of consciousness, we really don't know exactly, right, where the seat of consciousness, but we can safely assume that the seat of consciousness is where? In the head or the rest of the body? It's in the head, right? And we talk about gut feeling, and we talk about, in fact, in ancient times, many times the heart was like the seat of consciousness, right? Or the gut, for the Jewish people was the gut. And for the Greeks, for example, was the heart and so forth. But that's analogical language. That's symbolically speaking. Physiologically speaking, the seat of consciousness has to be where reason takes place. And it's the whole interaction between the brain and the mind, right? The brain being the physiological organ where the psychological process of the mind occurs, right? So I think it's fairly safe to assume that the seat of consciousness resides in the brain. And so really his case was kind of a philosophical case, but just to be clear that it's really a body transplant. If and when a brain or heart or a head transplant may be feasible, right? It's actually a body transplant. So it's not that a body is receiving a new head, it's that a head is receiving a new body. It's a different perspective, okay? Because who's the donor, who's the recipient? The head is the recipient. The head is not the donor. So that head will get someone else's body and not vice versa. All right, so Consent, of course. I mean, today, very, very obvious, and yet in past times, this was not as obvious, right? But today, totally unethical and illegal to do transplants without consent, or if the person is deceased or unconscious, proxy consent, right? We already talked about that. The payment issue versus altruistic. Some countries and some places are trying to get into payment of organs, but we still maintain it altruistic. We still keep it altruistic in what, at least in the Northwestern hemisphere, sadly, we know that this is going on. Payment for organs and tissues is going on in some parts of the world, okay? It's been in the news. It was in the news a few years back with a country. They were actually extracting organs from death row inmates, for example, involuntarily. And the reasoning was they were going to be killed anyway. Let's save their organs. And you can see that that comes straight out of a very utilitarian and pragmatistic mentality that disregards the integrity of the human person. And even though they are death row inmates, right, supposedly condemned from some heinous crime to die, to be killed by the state with the death penalty, that person still has value and dignity and integrity, and we don't have a right to go and take their organs without their consent, before or after killing them. So even in the extreme case that a country may justify the death penalty for reasons of protecting the rest of society and so forth, they don't have secure prison systems, etc. Unless that person actually, on death, the inmate has consented, it's hands off, all right? But yet it has been in the news. And this country, we'll go unmentioned, but you can look it up. When they were called by the United Nations on doing this, they said, oh no, we're not doing this anymore. What does that mean? That they were doing it. We're not doing this anymore. But they had been. The other case is known as transplantation tourism. Again, so there is the web, the www, the World Wide Web that we all use all the time. I'm on it right now with Zoom, okay? And then there's a sector of that that is called the dark web. Never, ever, ever go into the dark web because there's no depth to it, okay? There's no bottom to the dark web. And in the dark web, anything and everything is trafficked, including human beings. And so it exists, all right? And so transplant tourism goes into that, also organ trafficking and human trafficking and all this. It is extremely sad and horrible that this is occurring, but it's one of the dark sides of the internet. It allows for that to happen, all right? Be assured though, that security systems are also in the dark web, fishing for people who are getting into it, all right? So the feds will go, the federal government will go into the dark web to try to fish out, for example, child molesters and human trafficking and organ traffickers if they're occurring in the United States, either the donor, the recipient, whatever, and they'll go in there and scout out what's happening. These are people who are very savvy with computers and can do that, and they pose as donors or recipients or payees and so forth to catch people into doing this. And that's cyber crime, right? And that they can be prosecuted. Okay, so transplantation tourism is when a person who is typically very rich is on, let's say, kidney failure or heart failure, and they don't want to go on the list, or they've been on the list and it's not happening. They would simply pay and put together their own team. And it's sad to say, but today, anything from surgeons, nurses, and assistants will oblige, will consent to be part of the transplantation team, right, of transplantation tourism. Obviously, they don't have the value system that we have. They're unscrupulous and they're willing to do this for big money. And so this patient who has the money will put together their team and they'll go to a country, to a foreign country, into a hotel. And in that room, the hotel room, they will turn it into an operating suite, an operating theater, okay? And then they'll procure the organs, again, by hook or crook, or maybe paying, let's say it's a living organ, right? They'll pay the donor, who typically comes from an underdeveloped country, a person who is selling candy on the street, like the case that we saw of the lady from Singapore that took the in vitro babies from the in vitro embryos from the Australian couple, right? Remember, they were twins and so forth. So there are people in underdeveloped countries that for money will donate a kidney or a lobe of the liver or lobe of the lung, because supposedly they can keep on living and they get maybe $1,000, which is a year's pay or 10 years pay, really, for these people. And so it does happen. And they'll set up in a hotel room that whole suite of operating room, including the machinery and everything. Well, of course, it's going to be done the traditional way and with very, very high risk, but they'll do it. That's called transplantation tourism. It happens. It is horrible. It's totally unethical, of course, on many grounds, but it does happen, okay? The organ trafficking is associated with that. We know it's there, totally unethical and illegal, but it does happen. One aspect that may have some merit is this one that is called opt-in or opt-out. And this is controversial. It's been discussed, particularly in European countries, again, with socialized medicine. What is opt-in and opt-out? Very different from these other three issues, okay? In the United States, for example, right now, and in most of Europe right now, actually, it is the opt-in system. In other words, I opt into donating, right? And unless I opt into donating, my organs go with me to the grave, right? But opt out would be the opposite. Assume that people want to donate. Assume that people want to donate in the general population. And unless they specify, I don't want to donate, when they die, their organs will be harvested. That would be opt out. I opt out of donating. So it's flipping it. Of course, with the opt out, all of a sudden, we would have galore donations, right? Because people are dying all the time. And whereas not everyone who dies qualifies because they may have illness or other issues, genetic issues, or not be a match, etc. Overall, since so many people do die on a daily basis, right? There will certainly be an increase in vital organs available for donation. It would be cadaveric. And of course, I mean, the whole issue with opt-out is that once we're in the grave, those organs are going to waste, right? So some countries will have a very highlighted social conscience, and typically they're in socialized medicine, and the well-being, the social well-being is highlighted, okay? What do you think about our society? Are we very social conscience or more individualistic? Care for self. We're on the individualistic side, definitely. Market economy plays into that, you know, and so we are more on the individual side. Privacy and all that is paramount here in the US, okay? But there are other countries that have a very highlighted social conscience. Okay, typically in those countries, you don't see people in the streets, you don't see homeless because there are social structures that take care of the homeless. including mental health counselors and so forth, because many of the homeless, of course, they have mental issues. But of course, those countries tend to have very high taxes, maybe 50% tax, because all those social programs have to be paid, right? And they're paid by the population. There also tend to be countries that have high standards of living, so people earn more, but they pay more taxes. Like I say, maybe up to 50% tax, but they're earning more. And so it's a different system altogether. But what I'm saying is at the end of the day, they have a highlighted social conscience. And so some of those countries are considering the opt-out system. Okay. Now, it could be possible. I mean, it's not necessarily unethical to assume that people, when they die, they want to donate their organs. But what do you think should be required and what should be done in society at the social level if that particular country decides to go that route, the opt-out? What do you think needs to be done in society, beginning with children? Exactly. A massive education campaign that this is what is expected, that this is what is expected. And so to give ample time, ample information and time for people to opt out if they want to, because it has to be totally voluntary, okay? And so it's possible to envision this, but it would require, at least in my mind, it's speculative. So you see, now we're getting into the very speculative type of bioethics, right? Conceivably, a country may go this route of opt-out, right? But in my mind, they would have to mount a massive campaign of education to generate a culture so that the culture is expected that once we die, we donate our organs because we certainly don't need them in the grave. Okay, but there has to be ample opportunity for those people to opt out, even at the last minute. If they don't want, if they want to take their organs, basically, if they want to take, we have a slightly different take, or I say we in the Christian theology and philosophy and anthropology, but most people would consider that they are owners of their own body. My body belongs to me, and therefore everything inside belongs to me. Okay. We take a slightly different approach in Christian theological anthropology, that we're not actually owners of our body, we're stewards of our body, but we actually belong to God, right? And we return to God and so forth, but we are stewards of our body and we need to take care of our body. But ultimately, it's God's gift. We didn't ask to be alive, and so we take care of the body that the Lord has given us, just like with the possessions that we have too. But that has to be respected. If people want to take their organs to the grave, they're entitled to do that. Okay. So I can see it, but it would have to be this massive education campaign built in systematically into elementary school system, into the high school system, and not only public schools. They should actually have to go into the private schools too, right? Because they're part of society. So to know that by the time a person becomes a young adult, the expectation is that when they die, their organs will be harvested to give life to someone else. So it really has a very altruistic value to it. But with the stipulation that if the person wants to opt out, here are the forms that are filled out, here's the registry where it's registered and so forth. It also requires, kind of thinking aloud, what does it require also from the population at large? With regards to someone has to manage this, it would be an agency that somehow is related to the government, right? And so what also needs to happen in that society, a level of what? Yeah, checks and balance, so that there's another agency that monitors that and regulates it. But a level of trust, right? That the people generally trust their government, they trust these agencies. So these agencies need to have credibility with society, which is difficult. Do we trust the government, for example? Do we trust the current administration? Did we trust the previous administration? Yes or no? Perhaps, maybe, it depends. So it's we tend to be skeptic, right? and the proof is in the pudding, so forth. So like you say, regulation and agencies that regulate each other, checks and balances, has to be put into the system. So there's a lot that needs to go into the system for opt-out to work. The simplest thing for right now is the opt-in. But of course, that limits the pool of organs available, whether living or cadaveric. Right? So it's a discussion to have. So any comments about anything here?
The determination of brain death, that just means the organs are
Well, so,
because I remember
right.
2 types of death.
Right, 2 types of the determination, right? And one is brain death and the other one is not brain death. The other one involves what other vital organs? The classical heart and lung, which are together, right? Because if the heart stops, the lungs no longer function, so they go together. And that's also known as the cardiovascular determination, cardiovascular, right? That one is the classic that has been going on for decades and centuries. And does it require any instrumentation to detect it? Generally not, just feel for a pulse, right? Maybe they use a stethoscope, that little tube to hear the heart, but it doesn't generally require any instrumentation or sophisticated instrumentation, but it has to be a competent authority. Who's the competent authority? Some kind of a medical doctor, medical professional, healthcare professional. It may be a nurse practitioner, right, which is the terminal degree equivalent to medical doctor, but it's not technically an MD, all right? But it has to be a healthcare professional that is competent to determine clinical death. So that's the cardiovascular one, the traditional or classic determination of death. And the alternative, which is more recent, is the brain death, which is also known as neurological. That one generally involves more instrumentation. And what's the key instrument that may be used here? We want to see if there's any brain activity, right? Which is an electrochemical activity. So the EEG. So EKG is for the heart, but EEG, electroencephalogram, to see if there are any brain. So we talk about a flat EEG. A flat EEG is there's no electrochemical activity, and it's very safe to assume that that brain is dead, right? But including the brain stem, so that it's total brain. Not partial brain death, but total brain death. And again, the competent authority. So it leads back to the determination of death is both a clinical act and a legal act also. It has legal implications, right? Because as soon as a person is declared clinically dead, for example, the inheritance kicks in, the will, including the living will. So it has legal implications. All right. Well, that's basically what I have. Is there any overall questions or comments? The lecture, the course, the program, life in general. We're still alive after 2 years. Yeah, after COVID, I used to talk about there was only one BC in human history up until 2020. Before Christ, and after Christ, BC, we measure the years, why are we in the year 2021, which is about to end, 2021, 2021 years after the birth of Christ, right? So BC and after Christ. Now we got a second BC, before COVID and after COVID, which has really affected the world, independently of our beliefs. That's why viruses and bacteria and these illnesses are equal opportunity employers. They don't discriminate. It doesn't matter what belief we have. They're going to zero in. What matters is the immune system. That's really what matters. And that is associated with age. And that's why the third age, 65 or older, which is a fuzzy parameter, obviously, definitely be vaccinated. Okay. But even for the youth, be vaccinated. All right. Well, So the very last slide is just for all people to consider becoming a kidney donor. Of course, that's the pitch. But I also say that realistically, unless you actually have someone in mind, like a family or a friend who is on renal failure, right, on the list of the 100,000, you may want to wait, especially for women, to a little older, after the childbearing ages. And the reason for that, again, what happens with pregnancy? It taxes the body of the woman, you know. It taxes the body by way, because now that as that embryo and fetus grows, then it's a double circulation basically that the mother has to maintain, right? And so that placenta is putting pressure on the mother's metabolism, physiological pressure. And so it's better to have both kidneys healthy while sustaining a pregnancy, okay? So that they don't go into high blood pressure issues. And then that could also go into what is known as preeclampsia, which is high blood pressure during the pregnancy, very dangerous. In fact, that's what happened to the recipient, my friend that I gave the kidney to. She had high blood pressure since she was a young person. And during her pregnancy, when she was pregnant with her first child, she developed preeclampsia and apparently went into full-blown eclampsia. And when she gave birth, it shut down her kidney, her pancreas, and had the stroke. You know, so she almost died then, and all because of high blood pressure during pregnancy. So it's very dangerous. And that's why I recommend especially for women, to wait until after 50 to be safe. For men in general also, you know, a young person still doesn't know, has not fully decided what their life status is going to be, etc. Marrying, having children, so that also puts on pressure, not necessarily blood pressure, but it can indirectly increase the blood pressure of the man by raising a family, right? So generally after 40s or 50s, it's good to think about this, okay? It's an altruistic thing. And they take them now, they take kidneys until in the 70s for the donor. So it's a window there of about 24 years from the 50s to the 70s when one can consider being a kidney donor. And basically after 50s, we've at least lived more than half of our life. If the average lifespan is about 80, then midway is 40s, right? So at least after 40s, we can say, well, we lived half of our average lifespan. So anyway, something to consider. And that's it basically. So anything, Carolina? You're virtual today, last minute, but you were able to follow along?
Yes, Professor, everything.
All right.
Yeah, thank you for this program. These 2 years have been like really very interesting and a good learning, and
Okay.
to have the opportunity also to work in the volunteering for
In
the
Respect Life?
in the Respect Life was amazing.
Okay,
Well,
super, excellent. There you go.
yeah, I was still planning to do it, but the center there have
Yes.
closed.
Oh,
So
yes.
yeah,
Mhm.
so probably I'm moving to the one in South Bay that is in Hollywood. So
Oh,
they're
okay.
trying to organize it. Yeah.
For the Hollywood Center, yes.
Yes.
They have their main office there too, so.
Yeah.
Okay. Well, I'm glad that the internship was fulfilling and productive for you and the program as a whole. Of course, COVID really threw a monkey wrench in this whole thing. And so what happened was I had to postpone starting a new cohort. Let me wrap up for the purpose of the video, but I'm going to stop the recording and then we can continue here. But hold on. Yeah, stop recording.